If you're not already familiar with wintergreen the plant, then you're at least familiar with wintergreen the flavor. It's objectively the best flavor of Altoid, and it's been the main flavorant in root beer ever since sassafras got cancelled. This flavor is owed to wintergreen oil, and more specifically the secondary metabolite methyl salicylate, which is produced by a variety of plants but is chiefly sourced from the American checkerberry, Gaultheria procumbens. So far as genera go, Gaultheria has done pretty well for itself, consisting of roughly 283 species of shrubs, subshrubs, and exactly one tree. The wintergreens have found a place for themselves in just about every boreal or temperate niche worldwide. We even have one species in my neck of the woods. I've drawn it here with the flatwoods monster, two things I've never seen in life, which might as well not exist. But, interesting though they may be, this isn't a video about the wintergreens, or at least not those wintergreens. See, there's another group of plants not too distantly related which we've also given that common name, and in my opinion they're long overdue for the spotlight. This past summer I attended a field collection with Jess Leffler, who's doing her graduate work with a couple species from a broader group known as the pyrolas. Now, I've known about the pyrolas for some time. It's actually kind of difficult to hike in the Rocky Mountains without seeing one sooner or later, and they're an interesting bunch. Close cousins of the Gaultherias, both groups actually belong to Ericaceae, the family best known for blueberries, rhododendrons, and heathers. But this wasn't always the case. In the Cronquist system, which was the predominant taxonomic system prior to APG, the pyrolas were classified in their own distinct family, Pyrolaceae. Pyrolaceae was always kind of a satellite family. Phylogenists knew it was pretty close to the Ericas, but it was up for debate as to whether it should be consolidated. As usual, molecular phylogeny has a way of quashing such disputes. Now, as of my writing this, the debate now seems to be whether or not the group is actually a distinct subfamily at all, or a tribe nested within Monotropoideae. Look, just take it from me as a recovering plant taxonomy student, plant tax isn't as much of a field as it is a series of intensifying tension headaches for everyone involved. And if you can live your life as a botanist somehow avoiding cladistic disputes like this, just do it. Just do it. Please do it. I forgive you. So anyway, the first pyrola I remember seeing was Pyrola chlorantha. It was around 2018 or 2019 in one of my regular hiking destinations, and a couple feet off the trail there was this little cluster of plants mid-flower that just stopped me in my tracks. There's something very eye-catching about this group that when they're in bloom you just kind of stop and go, what is that? Chlorantha especially has these pale green flowers, not a common color among flowers, but it's always fun to see. Given the common name, I figured I'd crush up one of the leaves, and it smelled exactly like any other crushed up leaf. If this group expresses any aromatic pathways, that trait must have missed P. chlorantha entirely. Then for the next 5 years, this species fell completely off the map. It was unusual. It was like I had offended some sort of dryad who retreated back into Arapaho National Forest with P. chlorantha in tow. But from where they retreated, a whole team of species would soon make themselves known to me. No matter where they are in Ericaceae, it's indisputable that the wintergreens are a humble bunch. Compared to Gaultheria's 283 species, they pale in comparison with only 37. These species are unevenly divided between 4 genera: Pyrola, Chemophila, Monazes, and Orthelia. In addition, these species don't really tend to exceed their trophic comfort zone. They are all 201 understory perennials with sympodial ramets, connected by underground rhizomes. But for their minimal speciation, the wintergreens present you with some striking floral diversity. Of the handful I'm used to seeing, flowers will often vary wildly between species in terms of color, size, and arrangement. And if you're anything like me, God help you, then you've likely come away from this wondering, why don't we see these plants more often in cultivation? You'd think, with all their qualities, somebody might be growing them outside their natural habitat. And this is where Jess comes in. For all their qualities, the pyrolas have an invisible dependency which relegates them to their respective niches. One they share with another notable family, which, trust me, we'll get to sooner or later. You see, the pyrolas are all obligate mycoheterotrophs, which is to say that at some stage of their life they require mycorrhizal assistance, the nutritional aid of fungal associates, to become mature, fully fledged plants. Research suggests that some species are more narrow in their chosen partnerships, while others are more widespread, and that some species recruit this help specifically at germination, where others rely on it throughout their life cycle. But broadly speaking, this relationship, and moreover this level of reliance, is a characteristic trait of the pyrolas.
Because a lot of the interest in my project was like looking at like specificity, because it's so crazy that some of these have these like super specific, like with the pine drops. I'm pretty sure it's just rhizopogon and maybe even a specific species of rhizopogon.
Oh.
Versus like pyrola is
Yeah.
just like, who wants to party?
Yeah, whatever works. Any port in a storm.
Yeah.
What Jess is referring to here are pine drops, Pterospora andromeda, a species of parasitic plant that, so far as we can tell, allies almost exclusively with the fungal genus Rhizopogon. Now, pine drops are a part of Monotropoideae. Remember that closely related potential umbrella clade to the pyrolas? You might recognize the monotropes by their type species, the ghost pipe, an achlorophyllous parasitic plant which sources all of its energy and nutrients from allied mycorrhizal networks. This is kind of a thing with the monotropes, and is part of the taxonomic debate around these two groups. All monotropes are mycoheterotrophs, and many species tilt the scale all the way from mutualism to parasitism.
And so kind of one of the questions that we had is like, as you go further down on this journey, like become more mycoheterotrophic, is it a requirement to specialize, right? Is it a requirement to be more efficient? Because I assume, I guess I'm even assuming that specializing is more efficient, right?
Right.
But like, I'd have to assume that's why. Otherwise, why would you limit yourself?
Yeah. I guess it's different kinds of efficiency, right? Like,
yeah,
you don't want to end up in too narrow of a niche.
right.
Unless you're an orchid.
Unless you're an orchid, and then you just do whatever.
So Jess's work aims to characterize and correlate these fungal recruitments as they pertain to two species, Pyrola saurofolia and Chimaphila umbellata. In order to do that, she has to get at the roots of each plant, the point of contact between the plant and the fungus. As I mentioned before, the pyrolas are rhizomatic. An individual organism is a clonal colony branching out from these long underground stems. Root projections branch off from these rhizomes at little nodal intervals. They're as wispy and insubstantial as you might expect for a plant so reliant on its neighbors, and fungal DNA will be extracted from those roots and used to identify, if not the exact species of the fungal partner, then the generalized group that it belongs to. Knowing this, of course, not only helps with future conservation and forestry efforts, but it could also allow us to propagate these plants outside their local habitats. And I mean, come on. You mean to tell me after this whole video that you wouldn't want a pyrola in your garden? It's ridiculous. Hey there, Editing Sam here. I just wanted to jump in real quick and clarify that Jess's work is more specifically to do with the comparative host selectivity between these two species, and that the use cases I mentioned are pretty tangential and, if anything, far downstream of the project itself. But of course all this talk about ericaceous taxonomy and fungal associates and sympodioramids or whatever fails to really get at the fundamental question that brought me here in the first place. Do the pyrolas actually produce methyl salicylate? And would you believe me if I told you that this obscure group of plants known only to you, me, and Jess doesn't have a wealth of botanical literature regarding its phytochemical constituents? And the most I can really find on this subject is second to third hand evidence of Chimaphila umbellata being used to treat headaches, which at least suggests that it employs the salicylic acid pathway, and that it's apparently been used to flavor root beer, which is, promising. But a couple anecdotes don't make for a smoking gun. Unfortunately, it seems that if I want to find a local source of wintergreen oil, I'm going to need to employ the help of a cryptozoologist.